of our 6-day Atal-sponsored FTP on Next Generated Automated System. Today our resource person is Mr. Maharaj M. He is the founder and CEO of BC Bus Technologies, building Cyber, AI-powered cybersecurity SaaS platform. He is also an expert in exploring emerging technologies, cybersecurity for startups, SMEs, SMBs, and MSMEs. BC Bus Technologies Private Limited is a DPIIT certified cybersecurity SaaS startup delivering consulting and solutions in offensive security powered by enterprise blockchain and generative AI. Additionally, they deliver technical upskilling and reskilling in emerging technologies like AI, cybersecurity, and blockchain to enhance the employability of the candidates and acquire the skills required by the industry. Mr. Maharaj's background is, he has completed Master of Business Administration from Bharatiya University. He has also earned a certificate from the Institute of Company Secretaries of India. Welcome, sir.
It's a little bit sleepy, but I can help that. Thanks for the warm introduction. My name is Maharaj. I am the founder and CEO of a startup called Qubits Technologies. It's 3.5 years old, startup incubated in Coimbatore. I carry 16 plus years of experience in corporate, and last 5 years before I started the startup, I was in real estate, delivering government projects in IT as a project lead, project manager, delivery side of the projects. To start with, I've been to Ahaya like 3 years ago, and since our company is into products and services cybersecurity, it's a rare occasion for me to come to an academic institution for such a duty. So today is my officially like 125th session like this, direct session, close to 20,000 plus students and close to 1,200 plus faculties we have met face to face in the past 4 years of time. And I'm happy to be here. I try my best not to make you to deep sleep more. Okay, I try my best to keep the topic a little bit of connected to what you do. Sneha, thanks, special thanks to Sneha for assisting me in navigating the sessions from there. Okay. So, the topic for today is all related to quantum. Fortunately, few weeks ago, there was one director from Australia. He came to India. He is working with a company called, I will tell the name of the company, you can go and research. It's a Bangalore-based company having headquarters in US. The name of the company is QAU. Okay, you can go and check. It is one of the top 10 companies across the globe having both hardware and software and government funded. They have done some projects for Indian government and defense and some confidential projects as well. And we are expanding to other sectors in quantum computing, quantum cryptography, post-quantum cryptography, and so on. Recently, we had this discussion and we started working on something that will eventually come next year. By the time I got this opportunity to come to Atal to deliver a session quantum, I thought, okay, I'll go and try it out. And that's the reason I'm here today So I'll keep my session as much as simple English, not too much technical terms, so that you will have some takeaway at the end of the session. It's not about I go in depth and explain what is which law, what is the background behind this, because all these things and not like that. We will keep something very simple so that you will definitely have a takeaway by the end of the session. I believe most of you, almost everyone of you is from IT background, IT background, and we are going to talk about few things that is going to get connected with your post-graduation, after graduation. There are two things. One, most of the students after the graduation, they start with a full-time job. And there is another sector of students who start with the family business, or people who start their own business, becoming an entrepreneur, and some will take a existing problem and try to solve it using innovative solution, something of their own unique solution kind of thing. That's where the startup terminology comes up. And very few percentage go for higher studies as well. I don't see anyone beyond this boundary, either full-time job or a family business or own business or startup or higher studies, research and higher studies. Getting married even after graduation, I cannot comment about that. Okay, that may be also a choice. No comments. Now, since we are into cybersecurity for quite some time, in my startup for the past few years, and I was in the corporate sector, working in IT, delivered IT projects. Cybersecurity was part of my life for the past 9 years and so on. I'm going to connect the cybersecurity with quantum cryptography, quantum computing, and what is required for you to take away from the end of the session. Let's say physicist, not physician, let's say physicist talks here today. He will be talking about the quantum physics. Let's say a mathematician talking today on this session, he will be talking something related to the math side in the quantum side, quantum computing side. Okay, quantum domain. Since I am from the IT industry, since I am part of a solution that is building up in quantum and so on, we are going to talk about what quantum means to IT and the CS, what's the future of it, connecting with our technology that is running around us today, starting in AI, cybersecurity and so on. So I have like 4 slide decks. Completing this 4 slide decks will take around 2 hours to 2.5 hours. But I have been given like complete at 4:10 sharply so that nobody misses the bus. I have exactly, I'm starting at 3, I will be completing at 4:10 maximum. Maybe most of the slides I need to rush up, but I will give you the link, you can download it later. I will do the link to you now. So, first deck. Can you please go to the previous slide? Cybersecurity, offensive and defensive cybersecurity. Next. Next slide. Threat landscape, offensive, defensive, compliance, regulation, global comparison, cybersecurity. This is where we actually start. We are going to start with cybersecurity. We are going to talk about the major 2 domains of it, offensive and defensive. Third thing, what is the threat landscape that is as of today? What are the government regulations and compliances that we are expected to know, bounded to and so on? The last one is how quantum computing and quantum cryptography is getting connected to our daily lives and cybersecurity in the near future. That is how this slide is completed. Next slide please. Next. Okay. Why quantum? Why quantum cryptography? Why quantum computing and so on? We'll start with one smaller example. Let's say I'm fixing 2 lights here. One is blue and another one is red. Okay, when you see the shadow of the lights, you'll be seeing a blue light here and you'll be seeing the red light here. When I start reducing the space of the lights, okay, at one point, both of the colors will merge. What if we remove the borders of the light and we place both the light bulbs, blue and the green, to the red, inside a single holder and projected. At the same, when we project it, you will be seeing light rays from both the colors, and both of these light rays will come and deliver another color probably. We are not going to get into it. Why this example? Since you are an IT student, all of you might have read about the Moore's law that stated that for every 18 months, the size of your chip will start reducing and the value it delivers multiplies and so on. Until 2003, Moore's law was very much active when we started creating the chips for our processing power. How the the graphical, the processing unit works, we create a processor unit and there will be electrons under it, and these electrons will be talking to each other so that it delivers the results. But when you reduce the size of the chip, you start with a million transistors to billions to now Apple phone and then Mac and so on, there are trillion transistors inside. The size is getting reduced between the electrons that is communicated with each other. At one point, there need to be space between those two electrons to talk to each other. And since you are reducing the size, at one point, the electrons have to converge. If it converge, probably we may not be able to achieve the result that we expected to get. That size is 5 nanometer. Okay, in the chip. Beyond that, you won't be able to reduce it at all because electrons will lose that gap in between. We don't have a solution for this. That's that Moore's law is not active right now because we solved this problem using another completely different technology, which is quantum computing. So how this is connected to quantum computing? Now, if you see the traditional systems or laptops and desktop computers and so on, everything that we store, it is getting stored in the form of zeros and ones, binary, 0 and 1. If I say there are two sides of a coin and the value 2 is not stored as 2, but the value 2 is stored in the binary form, like a 0, 0, 1, 0. But what if we need to have another domain or another state where we need to have both of them? We need to know both of them. Take the example of the lights that converge, okay? Blue and red separately, you know blue and red. And you brought it in one single holder, blue and red. Even if one light is not working, even if the red is not working, even if the blue is not working, by seeing the result of the light rays, you'll be able to say which light is not working. But this is not possible when you are having your traditional computing that is like zeros and ones and so on. So that is where something in quantum, we have another slide, it's another state, we'll talk about that. When we talk about all these things in quantum, using the traditional methods, it is not always possible to solve such kind of problems. For example, if I ask you what is 2 into 2, you'll be able to say 4. If I ask you what is 222 million into 222 million, you put it in a traditional computer, it will give you the results. Okay? What if I give a number, it's like 2 trillion, 16 billion, 17 billion and so on, and I'm asking you, what are the two numbers when you multiply, you got that answer? Hope you get the point. I'm giving you the result. It's a very lengthy number, and I'm asking you, what are the two numbers when you multiply, you get this result? If you use the traditional computers now, laptops and even the AI and so on, you won't be able to achieve it. Okay, it's not going to happen at all. Why it does matters? Because that is a limitation of the current technology. Maybe you can bring a supercomputer and run calculations for some time. It takes some time. Probably after 2.5 days of running it, you will be able to find it out what are the two different numbers when you multiply, you got this answer. But this solution that we're talking about, the quantum computing, will be able to solve this within close to 100 to 200 seconds maximum. Okay? Why we talk about this? We are going to start with something in computers, one domain called cybersecurity, and especially for my favorite and the most important technology in cybersecurity, not only cybersecurity, for all IT to function, which is cryptography. Okay? You may have read about RSA algorithms, AES encryption, 128 has been discarded, companies have migrated AES 256 or so on. Example. What if I have a password in my banking account and the password is like 12 characters, uppercase, lowercase, special characters, numbers, and so on. And you are using a computer to break this and reverse the password to an actual value. If my password is like this, my favorite color is blue. Okay, in between I put special characters, uppercase, lowercase, all those things. It takes many years. We can say about 3 years, we can say about 30 years, we can say about 3,000 years. We don't know. It takes many years for the traditional computing to do all the mathematical calculations to find the actual value of, to break this. But what if quantum computer was able to break this and able to crack it? Where it is going to affect? What is the impact of it? That is a question that was solved like decades ago. They predicted this. Quantum computing and quantum cryptography and so on will become to regular usage one day, and it will be a threat to the current cryptographic algorithms. When you log into your banking account, for example, HDFCbank.com, you have an account ID, you have a password. Of course, this password is hashed and sorted, maybe a pre-decrypt algorithm stored in the backend of the DB and so on. I'm talking about normal SQL and NoSQL, not graph or vector databases. If someone is able to get this, okay, take these passwords, harvest it now, maybe after 5 years, when the quantum computing comes into picture, they'll be able to break these passwords and know the actual password. So they what are the opportunities that we miss to see right now to get ready so that something will be useful when you graduate? And it's like 4 decades we were using this binary 0 and 1, and in another, within short span of time, a decade, less than a decade, most of the applications will be adopting everything related to quantum cryptography, quantum computing. That is all about the next one. Now, if you look at this, the slide will be we will talk about latest But this example is taken to another example is like what happened to all the intentions of the countries in now the example root system they act as a complete system classes and they will be divided the food into branches. This is one side. What is the aftermath of it? When this attack happened, the hospital was unable to deliver access to the patients, ambulance dispatch, scheduled surgeries and so on. Nothing was able to be able to connect it in that time. It took some. So of course, the answer of the people was what happened. This is one major thing. Later on the news in the other law enforcement agencies tell them that you are under some virtual arrest and they demand some money, all those things. This is a ransomware kind of thing. Supply chain attacks. This is one 3 days ago. One of the top 4 consulting companies, big 4 consulting companies, as you know, E&Y, PwC, Atal and so on. E&Y is one application has been breached and they stole customers' data. E&Y is actually one of the big 4 consulting companies providing cybersecurity as a service to their existing clients. But how it happened to E&Y itself, that is the other question. This happened because of the supply chain attacks, which means there are solution providers as part of E&Y and hackers breached one application that is part of this solution that is part of E&Y, and through that they picked the customer's data, the client's data, and they published it on the data breach. This is called a supply chain attack. How it matters to you? Let's say you're building an application using AI to cloud, level, cursor, cursor, whatever it is. You are building an app, you are shipping it within 2 days or 10 days later, millions of downloads, and all this is good, okay? All fine. But what is the background, what is the software bill of materials part of this application? That is the question. What are the libraries is used? What are the components you used? And whether all these are supported by the initial release provider, whether this is free of any vulnerabilities and bugs and so on. What if some library holds a backdoor to the actual hacker and you bundled that component in your application and you released publicly and there are like millions of downloads and the hacker got access to this application and be able to download all the data. So this is an example for a supply chain attack. We will come to a stage where we will explain how migrating to quantum and adopting quantum cryptography, post-quantum cryptography migration, another thing called the CBOM, cryptographic bill of materials, all these things is required so that you won't be in a situation where such problems won't exist because we have adapted what is required to avoid such threat actors and hacking activities. Next, AI, of course, you may have, you could remember when ChatGPT launched 3 years ago, hackers were using ChatGPT to start creating malwares, and then it came to the knowledge of OpenAI, and then they logged, and then any query that you run, you will be able to get a code or you will be able to get an answer for it. But initially it happened. And still now, until today, of course, the other side, the unethical hackers, we will say in cybersecurity, they still use AI to generate cyber threats, cyber attacks, and so on. And we, from the cybersecurity positives of the good side, we use the same AI to mitigate and tackle these cyber attacks that is generated using AI. So AI plays a role in both sides. If I ask a question, now using Claude or Gemini or Microsoft Copilot and so on, I ask a question, will you be able to write a Python script to hack a website or break into a login page or so on? What would be your answer? Will you be able to write a code? Will you get a code? Will it execute successfully? Will the prompt that you enter in any of these GPT tools provide the solution or not? What would be the answer? Have you ever tried it? Whether it work for you or you get a response from the GPT tool that GPT tool won't support such activities as well. Next. Deepfakes, of course, this is another thing. It happened recently. One of the recent case studies for us. There was a company in Singapore. The chief financial officer was traveling to different parts of the globe, and one of the accounting department person got a call, and the CFO, chief financial officer, was telling to her to make a transaction of this value to someone's account, and without even a single person ever doubt, the transaction was completed by the accounting department. But later they realized it is not the CFO who called, it was completely a deepfake, including the face, including the background, including the voice, including the articulation of how they speak, everything has been cloned, and this call was made. Okay, it took some time to realize that how authentically that deepfake AI performed like the actual human, the actual CFO. That is the deepfake. Next. Next slide. I'm just passing, I'm skipping few slides so that we cover the main part first. Which threats hit which sectors hardest? Okay, one of the most affected domains in cybersecurity, and one of the top 5 domains or top domains, we say moving towards quantum in the next 7 years, 5 to 7 years, will be this, starting with healthcare, then fintech, then FMCG, then e-commerce and so on. So you have healthcare, financial services, manufacturing, government, retail, e-commerce. Next. Okay, offensive security. 2 major sections in cybersecurity, you would say. One is the offensive, another is the defensive. Offensive means there are digital assets and you take measures to protect it before the cyber attack happens. Let's say you have a website, you have a mobile app, you have a virtual machine in the cloud, you have a network infrastructure, you have applications, you have databases and so on, and it is accessible to the public. The measures you take to protect these digital assets proactively is part of offensive security. That we also call other terminologies inside it, called as red teaming, vulnerability assessment, penetration testing, and so on. Okay. Now the other domain is defensive security, which is like the things that happen after some attack happen. For example, what's her name? Sneha. Sneha got suspicious of her friend, and Sneha's friend went missing for 3 days, and you won't be able, and nobody is able to trace. Then you report to the law enforcement agencies. They step into the PG, the room, they check all this check all the rooms, and they take accusers from the laptop and other servers and so on. And then they want to understand what exactly happened and so on. Then when they investigated, okay, they found something not adding up to the life of the person. That comes under digital forensics, which comes under the defensive security. Why I told this example? Because defensive security happens after the incident happened. But in offensive security, you take proactive measures to protect something that you want, digital asset. Okay? There is another question. There is another domain called a SOC, Security Operations Center, SOC. SOC is 24/7, 360 days monitoring of a digital asset. And incident response, threat intelligence, level 1 and level 2 trials and so on, all part of it, SOC. That's also to be there in defense. Next. We covered this. We have covered this. The PAPT. Next. 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 usually. Now we spoke a little bit about offensive security, defensive security, and the SOC inside offensive, and VA, vulnerability assessment system, MDR, ADR, so all this terminology is part of the answer. This particular subject, as a student from IT industry, you are supposed to know. What is one mandate of the compliance requirement we all should abide, or we all supposed to know currently, and it is getting amended next year? Can someone answer this question? There is one act from India which applies to all of us, each one of us, every one of us, and it comes into picture next year, and comes into mandate as a mandate and enforced next year. Can anyone answer this question? This is something being discussed in newspapers, channels, and so on for quite some time. Probably since November 2025, and it was launched in 2023. Anyone? So they told me it's a session, not a Q&A. It is DPDP Act, okay? It is for the data privacy and so on, like GDPR, UK and so on. I'm not going to get into that. Let's talk the basics. When you go to a shopping mall, I mean, this is like some time ago. Okay, when you go to a shopping mall, you make a purchase. During the checkout, they are asking your personal information, name, mobile number, and so on. 5 days later, 6 days later, you get a message that you have an offer for your upcoming birthday, and this is a coupon code, or this is a percentage of discount and so on. Question number 1. Did you agree with that person in the checkout to send a message to you on your birthday or track your birthday and so on? None of us or most of us haven't done it. But how it happened, why it happened? How is like they harvested your personal data, that is how. Why is they are making money out of it, and it's a marketing strategy. What government says, if they are sending this marketing messages and so on, they are supposed to get your permission, that is called a consent. Consent is, may I send you the marketing messages? Would you be okay if I keep your mobile number in our system so that we send you at least a message once a month? I'm asking the permission and getting the permission stored in the system, that is called a consent. All this comes under this DPDP Act and compliances, and these are some of the compliances. GDPR for European Union, NAS2 for European Union, HIPAA, Health Insurance Portal Accountability Act in US, DPD of India, certain directives in India. Certain, I want to tell you one more thing, because this is also part of this quantum computing and the quantum cryptography that we are talking today. The most important thing. Let's say a cyber attack happened, Atal Engineering College Technology website has been hacked. How will you react? Who would do what? How would you react? If let's say you are the IT admin of this particular, managing this particular website, it is your responsibility to notify Minister of Electronics and Information Technology. Under this, there is something called asserting, that is where the cyber crime is reported within 72 hours of your hacking activity. That is one. Number 2, I don't want anyone to answer this question, but just take this question. How many of you are using Tor browsers? How many of you are using VPN? For what purpose we are not going to get into. But question, how many of you are using Tor browsers? How many of you are using VPN? Virtual private VPN apps. Few years ago, government mandated that. It's like 2 years ago. Government mandated that all the VPN applications should go to India's internet network. Second thing, the VPN logs should be accessible by the government even after the expiry of the logs, the retention, maybe next to 5 years. Let's say I did something today, okay? 19th July 2026, I did something using my VPN. 6 months later, some investigations happening. the government will be able to pull up my internet usage, internet activity through the VPN log, and if it is against law, I will be subjected legally under all the legal laws and so on. Why I am telling all this? Whatever you do in internet, you may forget, but the internet always remembers. It never forgets, not even a single activity. So that comes under this certain directives. Next slide, please. Give me back next. 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 Yeah, please wait. Okay. Why quantum? Why quantum? Why quantum cryptography? The actual topic for today. Three things. Today's encryption relies on problems hard for classical computers. Of course, we discussed about this breaking of today's cryptography when quantum computing comes to the picture. Number two, large enough quantum computer would break. Of course, it will break the current calculations, current technology, and also the security of everything. Third one, the hardware gap is closing faster than most things. That's what we spoke about, something called the 5 nanometer, and a lot of things behind it. Next. Okay. If you want to take a notes, you can take notes of this terminology, shots of the it's like factorization. What is a factorization? I am asking what is 2 to the power of 128 and you give an answer. But I give an answer and asking you to find what are the two numbers that when you multiply you got the number, that is called factorization. Okay, short algorithm is one that is relevant to the quantum cryptography subject we are discussing about. Next. How was now decrypted? This also we discussed in the beginning of the session. When you provide consent in the websites, it goes to the backups and it stays for some time. But what if someone is able to achieve a breakthrough in reversing or cracking those cached passwords in the DB? Eventually it will happen. And how we can mitigate it, how we can avoid it, there are only 2 ways, literally. One, you don't have access to the hardware, or you don't have access to the algorithm, you don't know what kind of logic they're using. That's number one. Number two, to be safer in that side, you better keep changing your passwords regularly. For example, I'm not sure how many of you know about this Cambridge Analytica, Facebook conspiracy for voting, rigging the votes that happened a few years in US elections. It's not this one. It's like a decade ago you may have read somewhere. If you go and check your Gmails and if you go to security, the tab will show that you last to change your password like 3 years, 8 months ago. If that is the status of your password activity, you are damn sure, your account is damn sure that it is part of this harvest now decrypted risk. What to do to avoid this, what to do to mitigate this? It's always recommended to change the password regularly. For example, once in 3 months. That is when you work for a company. Take an example in course of CTS and so on. There is a password policy. Every 72 days you will be mandated, you will be forced to change the policy, password for all applications. I'm not sure about how frequently you are changing the password. That is one. Number two, I've seen this trend, okay? People create accounts, Gmail accounts, they create a password and they go to different applications and every single application they provide this email ID and the same password that they have used for Gmail. So which means, if someone is able to crack the password for your Gmail or any of the applications that you have used the same password, they will be able to burn your entire history out. So it's always recommended whenever you create passwords in different applications, every time, always, create a new password, give a new password. like if my password is success at 2026 1 to 3, the next application I create, the password will be success at 1 to 3 hashtag dot something like that. So always there is an addition or reduction in the password, but I'm not going to use the same password like success at 2026 for all the others. Never do it. Next. Yes. Okay, we spoke about this when we introduced Y quantum cryptography and so on. What are the cryptographic algorithms at risk where the quantum computing and the quantum cryptography comes as a solution? I'm sure most of you have covered this as part of your syllabus. Public key encryption, key exchange, digital signatures, symmetric encryption, and hash functions. Okay, next. Next. Previous slide, please. Okay, now. All the major cryptographic algorithms have been marked as risk category, but when it is going to happen, is it going to happen in 2026 or it is going to happen in 2036? That is another question. So industries have started migrating to the post-quantum cryptographic algorithms already. We are thinking that it is in the theoretical level and that nobody have adopted it. For example, 1 year ago, last year, okay, MasterCard tried one public app access by the public applications one. They have adopted this quantum cryptography and it is at a live now. Only thing we are not aware that this is running in the quantum cryptography, the backend. And one more example I can tell you. If you see the quantum computing machines and so on, all you can see is like different kind of machine with tubes and so on. We are getting the order later. And it takes the qubits to function, and there are first one achieved 47 qubits, and now IBM has reached where there are like 1121 qubits, and most probably we will reach like 100 and 1 lakh qubits very soon, which will accomplish most challenging tasks. When this happens, obviously, all the applications that we are using, including the banking application, including the cryptographic algorithms, algorithms included in the mobile apps, everything will be at risk. And industry has already started migrating to post-quantum cryptographic algorithms. That is where when we told in the first place about a company name who started working on the defense, there is already a quantum network for the defense, Indian defense. There is already applications running in quantum computing. Of course, the front end is quantum, the back end is the traditional computer. Soon, whatever the traditional computer that we are having now, that activity will also be having the quantum computing in the near future. Next, QKD. These are the two major things that every quantum cryptographic news that you will see, or any paper that is coming in the semester paper in your curriculum will be having these two. One is the PQC and the other is QKD. Next. Okay, these are something. These are some replacements or some terms relevant to the current cryptographic algorithms. When we say about AES encryption, when we say about DeFi element, RSA, and so on. Similar to that, these are the quantum cryptographic algorithms, FAPS and then HQC, and there are more. We would say like around 27 algorithms are there like this in existence, not only in theory but also in implementation as well. Next. 8 reasons. We are going through the slide completely one by one. Next. Emerging quantum safe security vendor landscape. Okay, this is very important because 3 years ago, when we surveyed, okay, when government surveyed how many quantum related solutions or startups or companies in India in this domain, there are only few. IBM, Google, and so on. At the time, there are 1 or 2 quantum computers. Now we have like 12 in India, I think, maybe. And of course, you may have read the newspaper last month that led to the Google work on India's quantum mission and so on. These are all the vendor landscape. Who is working on what? Okay, that is the PQC. We have few companies in India, Q, Quantinum and so on in India. Q Labs from Bangalore, Cloudflare and Google, of course it is headquartered in the US. IBM, well known. IBM was the first one who came outside and told that our computer quantum computer achieved this much of we won't call it as quantum supremacy, but the achievements. Next. Okay, quantum computing can also strengthen cyber defenses, not just of course we saw that in the AI side as well. AI is used for cyber attacks and cyber threats. At the same time, AI is also used for mitigating those cyber attacks and cyber threats. It's like at one hand I provide the virus and inject you, and the other hand I hand over the vaccine or the injection to contain that virus from spreading to your body. Similarly, like how AI does it, how AI is misused as well, similarly quantum computing also not only can be a threat, but it also can be used to defend those attacks. Next. We saw about the appliances. Next. Okay, now global platform integration, India's active trusted identifiers. This question, we had this question in one of the university in Bangalore. There was a student who asked, he is actually doing some research in quantum cryptography since 2003. He asked this question: What are the job opportunities for freshers in quantum? 3 years ago, we didn't have much. Very rare, very rare. It's like 1 in a million, we can say. But the industry has changed. We have another deck that says everything about the career opportunities in quantum. We have another deck following this. Okay, these are the platform leaders and firms hiring related to quantum technology in India. Next. Next. Okay, so I'm going to stop here before I open the next slide. Of course, we didn't cover much technical in that because I see the dull phases, tired phases. I'm not sure about that, but I'll pass here to ask if you have any questions before we get into the career opportunities in the next slide. Maybe they can heavy next one. Or they tried for the first half I visit. Or else the subject is boring. Or else I can break the board up for 2 minutes. How about we talk something not technical but about quantum? What was the movie from Marvel Cinematic Universe that covered about quantum? Anyone? Maybe this question can bring up to your active mode. What is the movie from Marvel Cinematic Universe before age of Endgame? Before Endgame. What is the Marvel movie that spoke about quantum? Anyone? Yeah, friend side, of course, faculties, I don't want to ask this question to faculties. But the other side, Gen Z, obviously you may have an answer for this question. Nobody. You guys are not fan of Thor, Iron Man, Avengers Endgame, nobody? Anyone here? You guys know or don't know? Don't know. You haven't seen the movie called Ant-Man, first part of Ant-Man, Quantumania, and later that became they spoke about quantum entanglement there. Actually, we have one slide covering quantum entanglement. That is where we see the space between the electrons. This entire quantum subject is something that you cannot fully literally convey and make you understand, because we all work at, like, take a switch for example. It's 2 states, on or off. If I come and tell you there is another state, you look like this guy is a human or an alien kind of thing. Okay? So quantum computing is also something like that, because all we have seen in this past 30 years, 40 years of IT hardware is like chips, transistors, processors, bytes 0 and 1, all these things. But one thing, super precision in quantum. Of course, we can cover it. Quantum entanglement, quantum supremacy. There is a third state in all this thing. It looks like a myth, but actually it is reality. That's what I was about to tell. Yes, ma'am, please. Okay, next. Can you please go to downloads? We'll talk first one, career opportunities. Okay, we have two more slide decks. Of course, this might be useful to one of you. Can you just go to first screen? Send you slides down. Fit with. Fit with. Let's hold that. Please go to next slide. Next. Next. Okay. This might be interesting. The reason is 2 years from now, okay, 2026, 27, 27, 2021, 2 years from now. Okay, let's go back to the past. We'll start about the last 5 years, 5 to 7 years. There are some technologies called AR, VR, Metaverse, Web3, blockchain, and all of a sudden when AI came into the picture, nobody started talking about the blockchain anymore, except as blockchain and so on. Because AI is one thing that is the base for every single technology from now. Any hiring, any technology domain, any industry, anything be it, it's like they can't survive without AI. It's like that. Why it happens so? Take an example. I run a hospital and I have patients and I have patient-centered records and the PI, protected PH, for patients. And I do have historical patient medical history, for example, for the past 17 years. Take an example. If we summon like 20, 30 industry veteran experienced doctors to go through these records and identify the actual root cause of the problem, the issue, the recommendation of health and so on, it will take days and weeks and months probably, but we will never be sure that we are getting the right answer. It's all about assumptions and suggestions are coming out of the expertise of a particular physician. But when you bring it to the AI, okay, we have another slide that connects AI to quantum. When you bring it to the AI part of it, you feed all the data to AI and you take a sip of cup of coffee. Before you finish this coffee, the 17 years of medical, and this happened. There is one company in Coimbatore, they are working for one healthcare point of use case in CA, California. This happened in March 2026. We were the case study review at that time. This happened, okay, to demonstrate how their AI performed well. We ran the case study parallelly. One is a set of physicians assessing these medical reports and coming to a conclusion. Another one is AI coming with a report, with some inputs, the outcome of the report. The result is this. The problem was somewhere else, and every doctor was treating for something else for the past 17 years. And I'm not talking about the problem here. A told it is the some gland near to the throat that was the actual problem for the past 17 years, and the doctors missed this in their assessments of the patient. patient and they were treating something for 17 years and they were never able to cure the problem. And when they said it, when AI said it, it's not that. This is the gland that is the reason for the problem for 17 years. And they restarted the discussion again, and since March, April, May, June, July, okay, that was second review. Now they agree that the problem is not the actual problem they were treating for the 17 years, but it is the other one that found by A. By just going to the report. That is one current achievement in AI, we can say. Similar to that, 2 years from now, there will, of course, we have companies now itself in Bangalore that hire very unique and special requirements in quantum cryptography, post-quantum cryptography migration, because of government regulations. 2 years later from now, you will be able to see more quantum-related job opportunities everywhere. Maybe you can even expect a company coming to a campus center to our campus. Next. 4 broad quantum theory parts: hardware engineering, quantum software algorithms, application science and domain research, product business development, consulting. Hardware engineering, of course, it's not that easy to achieve. Very few have access to the hardware, and there are 2 places in the globe. We read it 3-4 months ago. There was one in Japan, another one is UK. They have a college academic lab where they are able to create a desktop-sized quantum computing for learning purpose. It's not in production grade, something they did months and years of research and they were able to create one. The current size of CPU is something that we can carry and the laptops and so on, but when you cannot carry a quantum computer in a backpack or a trolley at this moment, it requires a sophisticated engineering and assembling knowledge, but very soon we will be having something that works in a desktop. That kind of quantum computing is about to come in the production again after 3 years of that. That is the first one. Hardware, it's not going to happen now. But quantum software algorithms, of course, if you go and check GitHub and so on, there we have, I can give you the links, cryptographic algorithms and QSA, kit and so on. There are free open source software as well to work in the quantum computer. Application science and domain expertise, of course, we spoke about healthcare, fintech and so on. Product business and consulting, we have mentioned few companies across India and across the world. Next, entry-friendly quantum roles and what they actually need. I'm not sure how much you have heard about these terminologies or these opportunities, but this will connect with you probably when you graduate after 2 years of graduation. Quantum ML, technical analyst, consultant, junior quantum software engineer, junior quantum software engineer, entry level. Okay, next. What a quantum hardware can actually explain today? We are not going to talk about that. Quantum software, of course, we can talk about this. Okay, 20-25% comparable classical software engineering role in the same company, that's fine. India's national quantum vision. Next slide. This is something that we need to follow. This is something that we can look upon. We spoke about this Google's quantum computing initiative that was with the government of Telangana. That's also part of it. And there are a couple of places in Bangalore that are working right now. And there will be one in South India. I'm not sure it will happen in this November or next April, but it will definitely happen. So you can follow the news feeds and get an update on it. 4 thematic hubs are actively recruiting IA, Indian Institute of Science in Bangalore, IIT Madras with the CDAT, IIT Bombay and New Delhi. And 23% institutions are building quantum teaching labs. This is something new. 3 years before it was like 1 or 2. One is CDAT, another I'm not sure, but now we have like 23% institutions building quantum teaching labs. Maybe other than we have next year or the following year. Amaravati Quantum Valley, of course, you may have newspapers. Next. Where else to look for quantum opportunity globally? US, UK, European Union, Canada, remote hybrid roads. I'm not sure about remote hybrid roads yet. I don't have that data and information. Quantum physics, Canada, premium. Right, next one. Previous one. 35% of the quantum roads require TST. It's not easy achievable. Mainly research and hardware. Now, of course, if you go to the library in a foreign country, if you take books related to quantum mechanics, you will be able to see 100 books in the library. 100 different authors, 100 different publications, 100 different books. But if you take that is quantum mechanics. But at the same time, if you go and look for book related to quantum computing or quantum cryptography, you may have less than a dozen. And even in the dozen, only few books only few books will be able to make the context and make the reader to understand the concept. Not if you start to talk about the quantum algorithms and so on, within 2 to 3 months of time, I can challenge that everyone will go to deep sleep mode. Okay, that's for sure. Or else we will deserve a break from the subject. Okay, that's kind of the subject from what we are studying in the subjects. Next, internship fellowships and sustainability programs. Of course, last year or the previous year, I'm not sure, in the Smart India Hackathon problem statement released by Nati or someone, there was one problem statement related to quantum cryptography. They gave very clear, and there are very few institutions, students from very few institutions only took the problem statement and presented it. Notable employees across the quantum ecosystem, IBM, Sai, Xanadu, Ionic, Quantinuum. Quantinuum is another one, QNL Labs is another one. And we have others like that is coming like this. 20 plus companies across India. Next one. What is junior quantum business as in wiki actually? No. We are not going to discuss that. 5 things to learn quantum careers? No. Next one. Service careers, demand. Of course, this is something in current because I have interviewed cybersecurity candidates for almost 17 plus partner companies. Due to the initial screening, 1,400 plus candidates have been interviewed face to face in the past 2.5 years. The statement is this: we do have a lot of opportunities in cybersecurity for beginners. Anyone who completed their graduation to get into cybersecurity, yes, the industries have a lot of job opportunities. But how many students are actually qualified to get into cybersecurity roles? That is a question. I take a moment to talk a little bit about that. One, just building a Linux machine, installing Kali and running tools like Metasploit, Nmap, Wireshark and so on. The next day morning they update in the LinkedIn profile that they are a cybersecurity expert. They do. But when it comes to an interview, when they ask a question, something related to DNS and DHCP, something related to IT version for IT versus and we throw a scenario, and so they are unable to understand the question at all before they answer it. If only they understand the question, they will be able to answer. They are unable to even understand this question. Getting into the cybersecurity is really challenging, but it's really a rewarding career for the life. Once you get into cybersecurity, you will never be under a layoff category after 2 to 3 years. Never. It's not going to happen at all. Pre-COVID, during COVID, post-COVID, and until today, you won't be able to find one single cybersecurity company that laid off employees due to AI or even for any reason at all. You won't be able to find anyone. And another thing, talk about your seniors who graduated in your same department of the domain. You will be able to pick one senior and tell him that he started his career in cybersecurity and he is now jobless. No, you cannot find him. But you cannot do the same for anyone who started the career as a full stack engineer or app developer or DBA. The reason is getting into cybersecurity is really hard. But once you get into it, all you need is 2 years of patience to learn, practice everything. You cannot learn in like a weekend time, you can learn in 3 months at all. Because I myself been cybersecurity for 9 years and we have cybersecurity partner companies who have done like 500 plus cybersecurity audits for $1 million companies across the globe, Fortune 500, Indian government. There was one company in Chennai who did penetration testing activity for something that is in space, a spacecraft. They hacked it, they proved it, and the company is in Chennai. It's one of the partner company. The challenge is this: you get into the foundation, not a rocket science. All you need to know better is computer networking, cryptographic algorithms, and you pick a domain, web application security, or mobile, or cloud, or network, whatever it is. You learn the basics first. You practice, until you know all the vulnerability that exists, what kind of Linux resources that are going to help you to address these real-time problems, how you can deliver value to the customers. That is more than enough to get into a first round interview. All you need is not a job. All you need is an interview with the correct company and the regulated member. That one interview is enough to prove who you are, what you know, how much of value you bring to the role, and what you will be able to deliver. And from then on, it's your journey, it's your role. But the challenge is getting qualified to get into the first one of interview. You need to pick. There are two sectors of students. One, students thinking that I am getting a cybersecurity certification, I get a job. No, it's not going to happen. There are of course million certified cybersecurity professionals, but they are not getting a job at all. They are not able to get an interview. Another set of students, I know cybersecurity, or I did a cybersecurity graduation, my degree is specialized in cybersecurity, but still I'm not getting. It's not, that is not also going to happen. How much you have learned, how much you have practiced, how much of CTFs, capture the flag events you have attempted, how much of technical skills and you know, how much you can solve a problem or do a activity of VR or penetration test without the dependency of AI, that matters a lot. Next, entry-level service roles, L1 software engineer, that is level 1, entry-level one is the logs triage, junior vulnerability assessment and test tester, network security engineer, cyber security at the SASE, okay, endpoint EDR, I'm not talking about the hardware devices at all. Next, from software is to CISO. If I graduate now, tomorrow can I become the dean of institution? Definitely not. Maybe tomorrow can I become a HOD of institution? Definitely not. I need to build my experience, I need to become qualified, like I complete my PhD, I gained 12 years of academic experience even before I get into the interview of becoming a head of the department or a dean, like that, to become the chief information security officer of a company, which is the most senior role in cybersecurity across the globe. It takes like 10 to 12 years, and that is the graph of it. Next. Sensible to certificates but not job. We are going to cover specializations. No. Yes. Okay. What cybersecurity roles actually pay in India? We have discussed few roles in these slides before, and these are few. For freshers, a SOC L1 analyst, junior vulnerability assessment, 3.2 to 7 LPA is good for a beginner cybersecurity entry level fresher. The reason is take two students for example, one getting into non-stop or AI plus non-stop engineer immediately and a better salary, and one getting into cybersecurity with a lesser payroll. Now, 2 years later, okay, the same non-stop engineer may have like 20 to 30% hike, but the cybersecurity guy will actually double salary. Only the first 2 years is hard. After the graduation, for the first 2 years getting this experience, only the first 2 years is really hard, but after that, it's all green. The first 2 years is like, you need to have real patience, you need to upskill continuously with a lot of technical subjects and so on, to get into that better salary that's expected. I always say, no, we are not going to cover the next one. Company have to have next one. Next one, next one, next one, next. Wait 1 second. Yes. Converging skills, where cyber security and AI and quantum are coming into picture, all three. That is this section is all about. Entry neurons, post-quantum cryptography, migration engineer, ASIC engineer, okay, are moving from rapid mainstream on a 10 to 5 to 10 year horizon. Like we said, it starts from 2 years from now, 2026, 27, 2028 and onwards. Next. There was one more word there, previous slide. It is called T-shaped skill building. Okay? In corporate world, there are only two categories, I and T. I and T. When I work, let's say I work as a database administrator. Okay, I know only the databases. I know how to write SQL queries. I know how to handle Oracle DB migration, tables, schemas, join, inner join, outside scripting, everything. I know only one skill. Other than that, I won't be able to do anything. That is getting into one domain and becoming the master at it, becoming a subject matter expert at it. When you say T, you may have to cover a lot of things. What if I know only Oracle, but my next application, actually it is going on in my office, okay? We have built an application using our DBS of SQL, MySQL, and now they are building another application which is going to adapt to Postgre. The table, the DB, everything is going to change, but database migration has to happen. And this engineer, this team, implementation team, has to handle front-end, back-end, middle layer, databases, integrations, APIs, stress test, load test, fault tolerance, 24/7 delivery of this, because what if you won't be able to withdraw your money from the ATM after 6 p.m. in the evening? You won't like to have an account in that bank, right? If the bank says you won't visit an ATM after 6 p.m. and get a money, you need to wait until the next day morning. You won't be having an account in the bank. So all the applications are required to serve 24/7. That is a T. Okay, you get into multiple skill set, but at least one domain you are getting the root into it. Pre-COVID, hiring was focused like this. Front-end engineer, database administrator like that. And then the full stack engineer came into picture. Now they are no longer hiring a specific skill set. One guy has to, one person, one resource have to handle front-end, back-end, implementation, migration, DB, queries, sometimes even the DevOps, development operations, post deployment support as well. Next slide. Converging skills, quantum and AI. Next. 12th roadmap, of course, this is something very heavy in terms of technology, but it will happen. Next. 3 common mistakes that slows freshers down. You may hate this slide, but let me be brutal. Skipping the fundamentals for the standing tool, of course we do. Certification with no hands-on proof behind them, yes. Waiting for the complete skill before applying, yes. All these three things put you at risk when you are attending interview or when you are even hired and being the day of the job. Okay. Next. What actually makes a portfolio standard collector? No, we are not covering. Next. Yes, this is related to the quantum side. Okay. IBM Qiskit and the penny lane. This is open source. It's available free of cost. No need to pay libraries. Quantum universities and NQM programs. CompTIA secret to CH, please skip it. Community competitions, of course, like I said, there was one problem statement in quantum lanes, quantum they had a couple years ago, and so on. Of course, we have another update which is November or next April. That is one thing from the government, from local government in South India. So we'll have next. Careers and services, quantum careers and services next. No, it's too early to talk about this. Next. Yes. We spoke about quantum cryptography and the risk that is the current algorithms is having, and when are the full scale production adaptability of the quantum cryptographic algorithms, and then when they roll out post quantum cryptographic algorithms for the existing applications, obviously they will need, like how they need AI engineers now, they will need post quantum cryptographic migration engineers. first one. Cryptography engineer, quantum safe focus, quantum safe security architect, like we said, technologies will come and go. When we started this IT, I was learning about Pascal, Foxtrot. I'm not sure how much you heard about this, but we had C++. And when I was about to graduate, I mean the professors here, they know about this. There was a company called Sun Microsystems. They created this platform, they created this framework called Java. Java came into picture at the time, and the people told that Java comes and emerges as people start adopting, and it will kill C and C++. Of course, it didn't kill it. There are some companies still was using C and C++ and so on. But Java and the JavaScript came. It's been like 25 years when after Java, when Sun Microsystems were absorbed by Oracle at the time. Java was owned by Sun Microsystems. 25 years now, still we can see CVs 2026 and 2027 graduating students from Paral University, Sanjeevani, Reva, Christ University, all the CVs we have mentioned Java and JavaScript in the papers. We did it 25 years ago and still it is the same. And now, since AI come into picture, we can see all the AI tools and AI related terminologies in the applications. Very soon, you will be having quantum related terminologies or quantum related cryptographic. And next one, as long as technology exists, it doesn't mean what technology. Okay? Whether it is a C, C++, or Java, JavaScript, or current AI platforms, tools, and so on, as long as technologies exist, there will always be a need for a security architect. The reason is, every single technology has been created by a human, and when human does it, there will be always a loophole. Always, there will be always a backdoor. Take anything. Microsoft. It started with 95, Windows 95, Windows 98, and today we are at, I'm not talking about Microsoft server version, I'm talking about desktop version. We are at 8, 8.1, 10, and Windows 11. And last week, Microsoft, 2 weeks, 10 days ago, Microsoft patched 170 vulnerabilities in one patch. Why this is highlighted? Because even after this much of time, they're still patching some vulnerabilities in the operating system. So as long as technology exists, there will always be a need for security, cyber security. And when AI comes into picture, there will be a AI security engineer required. And when blockchain comes into picture, blockchain security will be required. And then when quantum comes into picture, there will be always required for post-quantum security architect experts. That is one role you may face after 3 years or 5 years down the line. Next, what you actually need to know for today, okay, skipping this. Certification, we are not going to cover everything now. Next, companies next. Post-quantum migration engineer, no. Next, 30 to 31, yeah. It will start, yeah, of course, we mentioned 2027. Today, next year, May 13, 2027, DPDP Act. And then Securities and Exchange Board of India and the Reserve Bank of India, they have this quantum mission. They have set some benchmarks and they have set some deadlines for banks and the fintechs. That's also happening. You may see many activities happening in Bangalore and Andhra Pradesh, because these are the two cities where, places where you may have seen more quantum companies or startups. Next. Yeah, next. That's it. Let's close this one, please. I have industry and the quantum computing basics. Okay, can you please open this? How much time we have, sir? Oh yeah, I exceeded the time. Okay, bit.ly/QNTL3. That's a link. You can download all these slides. So you can get it from Sar or Nam later. It's in public domain. You can download it anytime. Those 4 slides, close to 160 or 170 slides. It's overkill, but sorry for that. Thank you so much for your time. Any questions? I know you need to rush for your transportation. Sir mentioned it. Any questions?
So can you please repeat the website?
Sorry, ma'am.
Can you please repeat the website?
Ma'am, I will tell you. bit.ly, that's a short URL. QNTM3. QNTM3, uppercase. QNTM3. bit.ly/QNTM3. You can get the link from sir. Ma'am, sir. You can download this page. And please don't share it on social media, please. I have my email ID after. So thank you so much for your time and attention. I know some of you went into deep sleep more, I can see that. No offense, but still fine.